Good day, students! Kumusta? How was your weekend? I am Miss Ranalina Niano, your science teacher. And as usual, we are here for a new topic. Are you excited? Good to hear! But before that, let us refresh the topic that we had last week. Let's see if you still remember it. Are you ready? Shall we start? Great! Let's start the ball rolling. Last week, we had the opportunity to know atoms and molecules, right? Good to know that you still remember our last topic. But, do you still remember the concepts too? We'll see. I have your group of words and you must identify if that particular group of word describes an atom or a molecule. Again, you will identify if that particular group of word describes an atom or a molecule. Do you understand? Claro ba? Great! Let's start. Most fundamental and smallest part that can exist of an element. What is your answer? Correct! Atom. As we all know, atom is the basic unit of matter and the defining structure of elements. How about for number 2? Two or more atoms chemically bonded together. What is your answer? Correct! Molecule. Remember, atoms that are joined together will not be anymore called atoms, but rather, it will be called as molecules, correct. Number 3. Protons, electrons, and neutrons. What is your answer? Correct. Atom. Atoms are made up of 3 particles. These are the protons, electrons, and neutrons. Well done! Now, I am very much convinced that you really remembered and understood our topic on atoms and molecules. For this week, we'll be diving deeper into atoms by knowing more about its subatomic particles. And what are those 3 again? Yes, protons, electrons, and neutrons. Thus, our topic for this week is subatomic particles. And by the end of this topic, you are expected to be able to determine the number of protons, electrons, and neutrons in a particular atom. Kaya ba? Kaya! So, shall we start? Great! Atoms are best described through different atomic models. After a series of experiments and observations, the models have revealed the composition of an atom, and scientists were able to know that atoms are made primarily of 3 subparticles such as proton, electron, and neutron. I have here an illustration of an atom with its subatomic particles. Can you still remember which is proton, electron, and neutron? Let us start in the nucleus. Inside the nucleus, we can find a positively charged particle which is called as what? Correct, proton. Inside the nucleus, together with the proton, we can also find a subatomic particle which has no charge, which is what we call as? Correct, neutron. On the other hand, the very small negatively charged particles that orbit around the nucleus is what we call as what? Correct, electrons. Look at this table. What can you observe with the values? With the data given, what property and particle of an atom have the same values? Correct! These are atomic number, protons, and electrons. Next question. Which subatomic particles were added together for us to have the value of the mass number? Yes, this could be protons and neutrons, or electrons and neutrons, or it could also be atomic number in neutrons. Now, what is really the concept behind this? The number of protons in an atom determines the positive nuclear charge of an atom. Protons also determine the atomic number of an element. We can tell how many protons an atom of an element has by knowing its atomic number. For example, the element beryllium. The element beryllium has an atomic number of 4. An atom of beryllium therefore has 4 protons. Next, the element krypton. The element krypton has an atomic number of 36. What do you think is the number of protons? Correct! The number of protons in the element krypton is 36. In a neutral atom, the number of protons and electrons are the same. Together with protons, neutrons make up the mass number of an atom. To determine the number of protons, electrons, and neutrons, atomic number and mass number, we will just use this formula. Atomic number is equal to the number of protons, and it is also equal to the number of electrons. Therefore, if we have the atomic number, we can also get the number of protons and the number of electrons. If we want to know the mass number of an atom, we will just add the number of protons and the number of neutrons. If we want to know the number of neutrons, we will just subtract the mass number from its atomic number. It's easy, right? We may also use the periodic table in determining the number of the subatomic particles. Just remember the symbol for its corresponding property. Capital A for the mass number, capital Z for the atomic number, and capital X for the chemical symbol of the element. Let's have this example. Using the formula in determining the number of subatomic particles, how many protons, electrons, and neutrons does oxygen atom have? Looking into the given quantities, we have the atomic number, which is 8, and the mass number, which is 16. We are to find the number of protons, neutrons, and electrons. If we still remember the first formula, atomic number is equal to the number of protons, and it is also equivalent to the number of electrons. Therefore, if we have an atomic number of 8, the number of protons is also 8, and the number of electrons is 8 as well. Well, the formula in finding the number of neutrons is number of neutrons is equal to mass number minus atomic number. We will just subtract the mass number from the atomic number. So, if we have a mass number of 16 and an atomic number of 8, 16 minus 8 is 8. Therefore, the number of neutrons is 8. Did you also get the correct answer? It's easy, right? Let's have more examples. Determine the number of protons, electrons, and neutrons in the copper atom. For this example, you may pause the video to solve. Let's check your work. What is the atomic number of copper? Correct, 29. Therefore, how many protons are in the copper atom? It is 29 also. Correct. How about the number of electrons? It is also 29. You're doing great. How about the number of neutrons? Mass number minus atomic number. Therefore, 64, the mass number of copper atom, minus 29, the atomic number, is equal to 35. What is the number of neutrons of the copper atom now? It's 35. Were you able to get all the correct answers? Amazing! Let us recall the important concepts by doing the Check Your Understanding 101. Are you ready? Let's start. Number 1. What are the 3 subatomic particles? Correct! We have protons, electrons, and neutrons. Number 2. What subatomic particles have the same value with that of the atomic number? Correct! These are proton and electron. You're doing great! Number 3. The difference between the mass number and atomic number is equivalent to the number of blank. It is neutrons. Very good. Congratulations! You were able to determine the number of protons, electrons, and neutrons in a particular atom. How did you find this topic? Is it a thumbs up or a thumbs down? Wow! Really? Now, try to answer the activities found in your activity sheet. If you encounter a difficult question, just rewatch this video or do not hesitate to contact me. And that's it for our lesson. This is Miss Renalyn Añano saying, have a scientific and terrific way. Till next week, goodbye!